Two massive, invisible forces run the universe. The first is gravity, which controls the macroscopic universe, keeping planets in orbit. We understand it primarily thanks to Albert Einstein, who showed us how it keeps our feet on the ground. The second is electromagnetism, the force that powers everything from lightning bolts in the sky to the microscopic atomic bonds holding your own body together. But in 1919, physicists hit a wall. When they tried to combine the mathematical equations for gravity and the equations for electromagnetism, the numbers completely contradicted each other. The rules governing the universe refused to merge. Scientists realized they needed an entirely new perspective to make the math work. That perspective came from an obscure mathematician named Kaluza. He sent Einstein a letter outlining a highly unusual mathematical solution. Kaluza claimed he could make the math of gravity and electricity match perfectly. But to do it, he had to add a fifth dimension to the fabric of reality. The need for a unified theory was so strong that scientists had to seriously consider that our basic three-dimensional human perception might be an illusion. We are completely used to experiencing four dimensions: three of space, up and down, left and right, forward and backward, and one of time. If there really is an extra dimension of space out there, why can't we see it? And why can't we move through it? A few years later, a physicist named Klein proposed an answer. He introduced a concept called compactification, where a spatial dimension is curled up into a space so small it becomes invisible to us. To understand how this works, picture a long garden hose stretched across a backyard. From high above, a garden hose looks like a flat, one-dimensional line. Zoom in close, and a hidden dimension emerges, its circular circumference. An ant on this hose moves along its length, but also loops continuously around this curled-up dimension. Klein argued that the fifth dimension behaves exactly like the loop of that hose. It is curled up into a circle so microscopically tiny at every single point in space that humans can only perceive the large, long dimensions. If this tiny hidden dimension exists everywhere around us, what actually happens when a particle moves through it? Think about an amusement park teacup ride. When you sit in one, you stay in one spot relative to the rest of the park. You aren't traveling from point A to point B, but the spinning generates a very real physical force pushing against your body. This teacup effect applies to Kaluza-Klein theory. A particle sitting perfectly still in our three-dimensional world is secretly spinning rapidly around a tiny fifth-dimensional loop. This spinning generates physical momentum that bleeds into our visible world, measured as electrical charge. We perceive electricity as the physical sensation of momentum bleeding over from this hidden dimension. This equation shows the start of what physicists call the Kaluza miracle. By looking at the math through the lens of a fifth dimension, gravity and electricity successfully merged into one unified geometric framework. In this new framework, gravity is the bending and shaping of the large dimensions of space that we can easily see. Electricity is that exact same geometric bending, but happening exclusively within the curled-up dimension that we cannot see. Kaluza and Klein consolidated the governing rules of the cosmos into a single concept: five-dimensional gravity. To be clear, physicists still have no hard proof that this fifth dimension actually exists, and the original math Kaluza and Klein used had technical flaws. But the core concept survived, eventually evolving into modern string theory. This framework attempts to explain all particles and forces in the universe using 10 or even 11 hidden dimensions. Kaluza and Klein challenged the idea that human perception is an exhaustive guide to the structure of reality. Solving the universe's ultimate mysteries requires looking at reality from entirely new dimensions.